Hi guys, welcome to this new project where today we are talking about VLAN aggregation and VLAN aggregation and implementation. So first of all, you have to understand what is a VLAN aggregation and how does it help in uh, uh, layer 2 communication and also layer 3 communication. So first of all, at least we'll help to understand what is VLAN. So VLAN aggregation defines VLAN aggregation defines the super-VLAN and the sub-VLAN. Aggregation defines defines the super-VLAN and the sub-VLAN. So what is the super-VLAN and the sub-VLAN? So it starts with sub-VLAN. So sub-VLAN is an independent broadcast domain. It's an independent broadcast domain which has only physical interfaces. So we say sub-VLAN independent broadcast domain and has only physical interfaces. And what about the super-VLAN? So super-VLAN, the super-VLAN is a non-physical interface, no physical interface, and is used to create layer 3 VLAN if interfaces. Used to create layer 3 VLAN if interface. All right. So now the VLAN aggregation is just a composition of the super-VLAN and the sub-VLAN, where the sub-VLAN is an independent broadcast domain that has physical interfaces, while the super-VLAN has no physical interfaces. So by binding the super-VLAN interface to the sub-VLAN interface, link aggregation, not link aggregation, sorry, VLAN aggregation associates VLAN aggregation associates associates the layer 3 VLAN if interface to the physical interfaces. To the physical interfaces so that all the sub-VLANs can share one gateway to communicate with the external network. Communicate with the external network. So by binding the super-VLAN to the sub-VLAN interface, VLAN aggregation associates the layer 3 VLAN if interface to the physical interfaces so that all the sub-VLANs can share one gateway to communicate with the external network. So like for example, when you see our topology here, our super-VLAN is VLAN 4, which will act as the gateway 10.1.1.1. So all the sub-VLAN down here. So let me highlight. So sorry. So we'll use our sub-VLAN. Use the color to indicate our sub-VLANs. So let's mark it. So this is a VLAN. Let's say sub-VLAN 2. VLAN 2. Then this other one will be VLAN 3. Sub-VLAN. So also name it sub-VLAN. Sub-VLAN like that. So we are told that all these two sub-VLANs, so VLAN 2 and VLAN 3, they will have to share one gateway, so which is 10.1.1, which is like the super-VLAN, the IP address of the super-VLAN. So also we are going to use the Proxy ARP to enable communication within the sub-VLAN, between the sub-VLAN. So Proxy ARP is used to implement sub-VLAN communication. Sub-VLAN's communication. So we use our Proxy ARP to implement sub-VLAN communication. You'll find that this species on VLAN 2, they won't be able to communicate with PC on VLAN 3 because let's say this is department A. People in department A Then these guys are on department B. They won't be able to communicate until we implement the proxy ARP. Department B. So it's the proxy ARP that will be able to help PC in different departments, that's the PCs on different sub-VLANs, to be able to communicate. So that's the introduction about our project today. So it's important, first of all, to understand what VLAN aggregation is and the composition of a VLAN aggregation, so that now when we venture into configuring it now, you'll be configuring the things you understand. So let's check our network requirement. Come here. So network requirements, a company has many departments on the same network segment. To improve service security, the company adds different departments to different VLANs. That is VLAN 2 and VLAN 3. Each department that wants to access the internet and PCs in different departments need to communicate with each other. So like for instance here, like the PCs on VLAN 2 should be able to access the internet and should also be able to communicate with other PCs on VLAN 3. So this PC should be pinging with the PC on the other VLANs. So this is how our topology will look like. And let's see our configuration roadmap. So configure VLAN aggregation on switch B to add VLANs of different departments to super VLANs so that PCs in different departments can access the internet using super VLAN. Deploy proxy ARP in the super VLAN so that PCs in different departments can communicate with each other. So that's the network requirement. Now let's jump into configuration straight away. So let me show you how an actual router look like. Maybe some of you uh, have never seen how a physical router look like. So you come here, check on that. You'll now be see how the physical device look like. So this is how the physical device look like. This is the router itself. So you should know how to differentiate between a router and a switch. So the difference between a router and a switch is that a switch has several physical interfaces, while a router has fewer physical interfaces. Like for instance here, this router, it has a console port which is used for configuring, for connecting to maybe your laptop through the console cable, so that you'll be able to configure that router. Now, then we have got the ports here. We can see there are 8 ports. And let's now see for the switch. You come and pick your switch here and see how many physical ports that the switch has. You see here, the switch has like 24 ports. There are so many. And you can power it on or power it off as to powering option. So once you see the number of ports, you'll be able to know this is a router, this is a switch, because sometimes they're the same size, the same weight, and you'll be not able to differentiate which one is now the router if you don't see the label. Okay. Again, maybe some of you don't know how to set a topology. Like for us here, you found if I already set the topology. So if you don't know how to set the topology, you just come and pick your devices here and you drag to the space here. After that, use the connection here, choose copper, connect Ethernet, connect according to the topology setup, and you'll be able to set up your topology successfully. After that, you just highlight and you right click on the space there and you start. Once you start, the device will be ready for configuration. So once you see the interface here has turned from red to green, means that our interface has been started successfully. So this is not where our focus is, so we'll remove remove those devices and continue with our main task today. So as you can see here, we'll start with our switch A here, and switch A has got how many interfaces? It has 5 interfaces, gig 1 up to gig 5. So we are going to configure layer 2 parameters. So that is the link type, and also allow the VLANs that will be required to pass. So it's important to understand uh, the link type. So we have got 3 link types. We have got the access, hybrid, and the trunk port and the trunk. So here the interfaces that are connected to the end device, that are the terminals, those are the access interfaces, while uh, the interface that are linking to maybe 2 switches or uh, a switch and a router, those are called the trunk port. Our network doesn't look stable. You see it is going on and it's coming up. It will give us a really hard time, but we'll work with it. So first of all, what we do is we jump into our switch. So first of all, you undo the terminal monitor to stop the pop-ups. So say SY, enter the system view, then you change the device name. So this is switch A. So in switch A, we have got several interfaces. So we have got how many VLANs? We have got 2 VLANs. So we create a VLAN. So VLAN batch 2, 3. After that, we create the interfaces. So interface gigabit 0/0/1. It is a link type. So port link type. Port link type access. Then we go to the next. Say quit interface gig 2 gig 0/0/2 port link type access. You can as well use the upper arrow key to review the previous then you edit. So we get gig 3, enter, then the link type is access. So go to gig 4, enter, port link type, this is an access port. Then go to gig 5. Gig 5 is the one that connect to the upper switch. So you say that okay, let's fuck out first quit. After that, we are going to add these two interfaces into VLAN 2. Then we add the other 2 interfaces into VLAN 3. So come here, say VLAN 2. So port gigabit 0/0/1 to 0/0/2, and also add VLAN 3. Add VLAN 3, and the interfaces to be added are gig 4, gig 3, and gig 0/0/4. Let's display this. You see under that VLAN there's nothing configured. Why? And the configuration has taken effect. So what has taken place is that it has been captured in the interface itself. So when you quit, then go into the physical interface gig 0/0/1, then you display this. You see, the default one has been captured. It's the same way we used to always configure, like after we configure the access, we give it the port default. Like for example, let's quit and let's use the interface that we want to use in the practical. So maybe it's say gig 10. So interface gig 0/0/0/10. Then port link type access, sorry. After that, we will give it the default VLAN of the port default VLAN 10 port 2. And display this. You see the configuration is still the same with the configuration we had up here. It's just the method that we've used that is different. So it should not worry you or should not challenge you. So I'm going to clear that. Okay, we won't use that interface, so there's no need even to clear it. It won't affect our configuration. So after that, we quit. Then we go to the interface that connect to the upper switch, that is a trunk port. So we enter interface gig 5, gig 0/0/5. We give it the link type, port link type trunk. Then we tell it to allow the sub-VLAN to pass. So port trunk allow pass VLAN 2 and 3. Wait. Control. Then you save the configurations. Say yes. And you make sure you also save it on the actual device. So this switch A here will just act as the forwarding switch, while switch B will be the aggregation switch. All the aggregation stuffs will configure here. The Super-Vlan will configure it on the switch B, and also the ARP proxy will consider it on switch B. So we are done with switch A. So we go to switch B. So undo terminal monitor. Then you change the device name. So this is switch A. Switch B, I mean. On switch B, we are going to configure the interfaces. So we have got gig 1 and gig 2. So interface gig 0/0/5. That's a trunk port because it connects to the downstream switch. Port link type trunk. Then you allow the sub-VLAN to pass port trunk, allow pass VLAN 2 and 3. After that, we configure also the upper interface. So you quit interface gig 0/0/1 gives that also a trunk port link type trunk. Then tell it to allow pass port trunk, allow pass VLAN 10. In the upper stream here will only allow VLAN 10. So VLAN 10 to pass. So that we quit, and then we create the VLAN IP addresses. So interface VLAN if 4, then we give it the IP address. So the VLAN doesn't exist. So let's create the VLAN. So VLAN batch VLAN batch 2, 3, 4, and 10. Then you enter the VLAN if4, give it the IP address of 10.1.1.1/24. Then you create for VLAN 10 the IP address for VLAN if 10. Enter, you give it IP address of 10.10.1.1/24. Save and quit. After that, we are going to add the sub-VLAN into the VLAN, the super-VLAN. So enter VLAN 4. Then we aggregate VLAN. Then we add the two VLANs. That is VLAN 2 to VLAN 3. After that, we quit. Say yes. Quit, and you save the configurations. Say yes. And you also save it on the device so that everything is saved. Then we go to our router up here, which is on the internet. So you undo terminal monitor. After that, you change the device name. So you give it, this is router 1. On router 1, you configure the interface that connect to the downward switch. So interface gig 1, interface gig 0/0/1. You're going to give it this is a layer 3 device, so we want to turn it to a layer 2 interface. So do port switch so that we will be able to configure the layer 2 parameters. So then port link type trunk, port trunk, allow pass VLAN 10. Quit. Then you enter the VLAN interface, then you configure the interface IP address VLAN if 10. VLAN doesn't exist. Let's create the VLAN 10. Then you give the IP address. So IP address of 10.10.1.1/24. Let's see if we can configure the interface on the downstream switch, that is .1. So ping 10.10.1.1. It's able to ping, so means that the link here is up, the link that connects the router and the switch. So then we are through with our router configuration. You save, and you also come and save it on the device. So we want to check if can we reach our internet while we are on PC1 or PC2 or any of the other PCs. So you come here, you give this PC's IP address that is on the same network segment as the super-VLAN, that is VLAN 4, VLAN if4. So they must be on the same network segment. So say 10.1.1. Maybe let's say 4/24. and the other one here is 10.1.1.8/24. You see, they are on the same network segment. Why? Because 10.1.1, come here, 10.1.1 is the same as the network segment of our Super-Vlan, that is 10.1.1. So we give also these other pieces are the same, 10.1.1.10/24. I also come and give the other PC of 10.1.1.12/24. Okay, so now the department A, the department B. So now let's see if maybe we can ping our gateway there. So we give it IP address of 10.10.10. Sorry. .1.1.4. Then our gateway is /24, so it will be 2.255.255.255. So here there are two ways you can assign your IP addresses. Either use the manual mode or the DHCP mode. So for our case, we are using the manual mode, that is the static. The DHCP is automatic assignment of IP addresses. So when you click apply and you come to the command and try to ping the gateway, ping 10.1.1.1, it's able to reach our gateway. So we are able to communicate with our gateway. So let's also come to this other guy, assign it its IP address. So it is 10.1.1/8. The default is 255.255.255. You apply and try ping the gateway 10.1.1.1. It's reaching our geteway. So it means that the link from this PC1 to the switch B is in up state, so it's able to ping. Now let's see if these two PCs can communicate. First of all, let's also give this other PC's IP address. So 10.10.255.255.255. Then you apply. She'll also be able to communicate with the gateway. That's successful. Then you come into this other PC. Also, you assign it IP address of 10.1.1.12. The subnet mask is 255.255.255. You apply. Test ping 10.1.1.1. It's able to ping successfully. And let's ping about the pieces on these pieces on the same sub-VLAN. That's the pieces on the same department. Let's see if they are able to communicate. 10. 10, they are able to communicate successfully. And what about, can they communicate with these PCs on the other VLAN? Let's test and see. So you come on this PC and you ping .4 destination host unreachable. Means that PC3 here is trying to transmit the packet, but it can't find the destination. It doesn't know where the destination is. So from that is where I will implement our ARP to enable communication. And what about, can I ping my router on the internet? Let's see. Ping 10.10.1.2 destination host unreachable. Means that this PC here, it doesn't know about where this router is. And what about, does it know where the interface of 10.10.11 on this switch 1 is? Let's test. Destination host unreachable. It doesn't know about that that address. So we come here, switch. So we are going to set our static route here. We're going to tell this switch to forward any route to the upper stream. So we come on switch B, say IP route static, give it any address. Let it find any address, should forward it. So the next hop will be on .2, so 10.10.10.1.2. Then you come also here, you make sure it's bidirectional. So IP route static, then give it any address 0.0.0.0.0. Then the next hop will be .1, 10.10.1.1. The next hop address does not exist. So let's come here and see if the VLAN if interface was given an IP address. So interface VLAN if 10, this, it is here. The next hop address is invalid, and can we ping that interface? So ping 10.10.1.1. It's able to ping, but the router can't identify that next hop. Let's check. We are trying to troubleshoot our network. See where the problem is. Let's see. Okay, we are still troubleshooting our network. Sometimes the problem we face is that when the link goes on and off, sometimes when you try to configure the route, when the link is down, the router won't know where that next hop is. So let's try it again right now. So IP route static. So we give it any address with the mask of any. So our next hop will be 10.10.1.1. Yeah, the command is now able to go. So let's see if we can ping. Of course, we can ping. We can ping the downward switch. Can we ping now our gateway 10.10.1? It's still not able to ping. It's telling a destination host unreachable. Why? Because we've not configured the gateway on this PC here. So like the PC1 is trying to forward packet to the upper stream. When it gets to the switch doesn't know about where this packet is destined. So it comes up to switch B, then it gets terminated. It's like the same case where like maybe you are given a letter to take to the HR. You get to maybe the IT building and you don't know where the HR office is. When you get there, you'll find the watchman. The watchman will direct, you'll ask him where the office of the HR is, so he will direct you to the office of the HR. So that will be the role of switch B. It should be able to know from where are you and where are you taking these packets. So we come on PC1, we give it the gateway. So the gateway is 10.1.1.1.1. Let's apply and see now if it's able now to ping. Okay, it's now able to ping, meaning it is sending packet. When it get to this one, it's able to know, okay, this packet was forwarded to me. I need to forward it to the destination and find from the route we configured, the route will be able to forward it to the upper stream. Now let's see if we can ping dot two. Okay, we are able to communicate with the dot 2 here. Let's see the other PC. What we do, we come and give it the gateway 10.1.1.1. Apply, then you ping. should be able to ping right, and it should also be able to get to the other route on .2. That count was successful. There was no packet loss. So you come to this other PC also, you give them the gateway, then .1 .1 .1. Come to this other PC, you give it the, oh, the gateway, you apply, and you try to ping, see if you can reach. Let's see if you can reach our network 10, our external network 10.1, 10.10.1.1. Okay, that's a successful count. But still, we are able to communicate up to the upper stream, but we can't communicate interdepartment. The interdepartment communication is not possible if we try to ping 10.1.1.1.4. You are told destination host unreachable. It doesn't know about that destination. So when you come here in our notes here, I said by binding Super-Vlan to the sub-VLAN interface, VLAN aggregation associates layer 3 VLAN if interfaces to the physical interfaces so that all the sub-VLAN can share one gateway to communicate with the network. So like this one, they shared this other gateway. So that's where we set the gateway. They share gateway to communicate uh, with the external network, that is the internet. Now, the part we are going to implement is now this one here. You're going to implement this part here. We're going to configure our proxy ARP to able to implement sub-VLANs communication. So that meaning that PC on VLAN 2 should be able to communicate with PC on VLAN 3. So you come here on this switch. So you quit, enter into the interface VLAN if view, VLAN if 4, then you give it the proxy, you give it the proxy, you give it the PRP proxy, question mark. So in the ARP proxy, when you question, you are able, either you enable proxy, so the enable command will able to enable proxy, the then inner sub-VLAN proxy help proxy ARP within a VLAN. So then the inter sub-VLAN proxy is proxy ARP between VLANs. So for us, this one is the proxy between our VLANs because we want these VLANs to communicate with the VLAN 3, VLAN 2 to communicate with the VLAN 3. So we'll come here, we say proxy ARP proxy, then proxy ARP proxy inter VLAN proxy, then we enable and we enable. After that, quit. Then save our config and let's now see if we are able now to communicate with the PC on the other side. So we come to this PC, then we ping .10, ping 10.1.1.10. A successful count now. So it has been reached successfully. Let's come on this side and let's try to it be bidirectional. So ping 10.1.1.4, a successful count. So that's was all it about, guys. We were to implement VLAN aggregation and we had two steps. Step one was, the first step was to enable communication with the external. Then the second step was to enable communication between the sub-VLANs. So thank you guys for watching. Remember to subscribe and also like and share your comment in case you didn't get something well and you need clarification. I'll be able to get to you as quick as possible. So thank you, and let's meet in our next classes.